find the area of a triangle using trigonometry is actually quite straightforward. Let's have a look at the proof. Now I need to start with the naming conventions for triangles, which is that if you've named a triangle using uppercase letters for the vertices, then you need to use the same letter for the side that is opposite that angle, but lowercase for the sides. So, what do we know already? Well, we know that the area of a triangle is half times the base times the height. Now we have the base here, let's call that B, but what we don't know is the vertical height. So if we drop a line straight down here, because this is not a right angled triangle, but we can make it into two right angled triangles, and we call this H for height, we can come up with some expressions for H that will help us to use this formula. So what do we know about this right angled triangle on the side here? Well, this is the opposite side of this angle A, and this is the hypotenuse, isn't it? So we can say that the sine of A is equal to opposite over hypotenuse. Now, rearranging that for height, we can say that height is equal to C sine A. Now, all I've done there is, whoops, I need to use a lowercase c, C sine A. All right, now we can use our formula that we already knew. So we can say area equals half times the base, now the base is B, and the height, well, we've now got an expression for the height, which is C times the sine of A. All right, now we could have named these triangles any which way we like. This could have been C, this could have been A, that could have been B. So let's have a look at how we can make this formula into a form that's really easy to remember. Well, it's got a B and a C and an A in it. It can be written three ways. We could say that it's half AB sine C. We could also say that it's half AC sine B. Now what's going on? Well, whichever angle we've used the other two sides, haven't we? So if we've got an A, it's BC, and if we've got C, it's AB. Now this is my favourite version of the formula. Area equals half AB sine C, because it's as simple as ABC, nice and easy to remember. Now what does it really mean? Well, we'd better write this down, where A and B are sides, and C is not just any angle, but the included angle. Now, what do I mean by included? Well, between A and B here is this angle C. It's like the mouth in the middle of the jaws, if you like. And if we were using these two sides, we'd need to use this angle. If we were using those two sides, we'd need to use this angle. You must use the included angle. So this description is really vital. Now, to use this rule to find the area of a triangle, all we need to do is identify the information we need. We must use the angle that's the included angle between the two sides that we have. So here we've been given a red herring. We're not going to fall for it. We're not going to use that 45 degrees. We start by writing our formula. Area equals half AB sine C. Even if we have no A's, B's and C's here, if you write this down every time, after a while you just know it and it's really easy to remember. Then we substitute in what we know. We need two sides, and we need the angle that sits between them, the sine of that angle. Now, 50 degrees, I don't know the exact values for that, so I'll have to reach for my calculator. Now, half of 72, that's 36, times sine of 50 degrees gives me 27.6 metres. Whoops, 27.6 metres squared to one decimal place. Now, two important things here. I've rounded it off, so I need to say what level I've rounded it to, and I need to include units. And don't forget that if we're working in metres, we'll have square metres as our units here. You can use the same formula to find other things. For example, if you know the area and you know two of the sides, you can find the missing angle if it's the included angle between the two sides that you know. Also, if you know the area and you know the angle in one of the sides, you could find the other side. So how do you do it? Well, start by just writing the formula as per usual and substitute in what you know. Here we know the area and we know two of the sides and we don't know the angle. Tidying up here, half of 56 is 28, so I've got 20 equals 28 times sine theta. Now to get sine theta on its own, I need to divide both sides by 28. So I'll have sine of theta equals 20 over 28. If you want to simplify that into 10/14 or 5/7, that's totally fine. Now, reach for your calculator, and we want to find, actually, I've reached for it too early. I need to write down what I'm going to do, which is to find the inverse sine of 5/7. Inverse sine 5/7 is around about 45 degrees. It's 45.6 degrees to 1 decimal place. Now at this point, you'll look back at the picture and say, sure, 45.6 degrees could be the angle we're looking for. But one thing you need to be aware of, just like with the sine rule in its ambiguous case, when you're using this rule to find an angle, there is more than one answer. What if theta was obtuse? Now to find your obtuse answer, do 180 degrees minus 45.6 degrees, and you'll get your other answer, which is 134.4 degrees to 1 decimal place. Now, what's going on here? Well, if we had an obtuse angle here, let's say we had 134 degrees, we could still have a triangle with 7 and 8 centimetres, and the area of that triangle would actually be the same as the area of this triangle. So there are just two legitimate answers to a question like this.